All right, so today we are on double angle identities. The learning target here is I can use the double angle identities to find the double angle values. All right, so does the sine of 60 degrees equal 2 times the sine of 30 degrees? Well, let me kind of go through these. So let's first see what is the sine of 60 and what is 2 sine 30. And then we'll see if those two equal each other. So let's recall from the unit circle here. So this is 0 degrees, this is 90 degrees. Halfway here is 45 degrees. In here we have 30 degrees. In here we have 60 degrees. So we need to know what the ordered pair there is at 30 and at 60. So at 30 degrees there, we have the square root of 3 over 2 and 1/2. At 60 degrees, we have 1/2 square root of 3 over 2. All right, so test number 1, it says we have to find the sine of 60. So sine is 60. Remember, sine corresponds with the y value on the unit circle there at 60 degrees. So the sine of 60 there is a square root of 3 over 2. All right, so then at 30 degrees there, we have the sine of 30 degrees. That corresponds with the y value at 30 degrees there. So that is 1/2. So this becomes 2 times the sine of 30, which is 1/2. And so if I multiply that, 2 times 1/2 there is simply 1. So does the square root of 3 over 2, does that equal 1? No, they're not equal to each other. So they do not end up equaling each other. So what does the sine of 2 theta actually equal? It equals 2 sine theta cosine theta. So these are our double angle formulas here. We have the cosine of 2 times theta, which is cosine squared theta minus sine squared theta, or you could use 1 minus 2 sine squared theta. So depending upon the information you're given, if you're given the sine of theta, I'd use that second formula. If you're given the cosine of theta, then you could use the third formula. If you're given both of them, you could use the first one if you wanted to. So it's just up to you, depend upon the information you're given. And then the tangent of 2 theta is either 2 tangent theta over 1 minus tangent squared theta, or you could just find the sine of 2 theta over the cosine of 2 theta. So if you just found those two values, then you could go ahead and find the tangent of 2 theta there using those two values. And again, these are on that Unit 4 identity sheet that's provided there underneath the notes. Or you can write them down yourself. So let's go ahead and let's do an example here. So we're given here a sine of x is equal to 1/2 and the cosine of y is equal to -3/5. X is in the first quadrant and y is in the third quadrant. So right now, letter A there, we're trying to find the cosine of x. So to find that, we have a sine of x. So we can use cosine squared x plus sine squared x equals 1. We don't have cosine, we're trying to find that one. We have sine, so the sine of x there is 1/2. So now I can just square 1/2. I square both the numerator and denominator. I end up getting 1/4. Now I want to get the cosine squared of x all by itself, so I can subtract 1/4 from both sides. So now I can simply get a common denominator. My common denominator here is 4. So then 4 minus 1, there's 3, and then write down the common denominator, 4. So I'm supposed to find the cosine, not cosine squared, so I need to take the square root. And don't forget my plus or minus there on the outside. So we get cosine x here. Over here, we get plus or minus the square root of 3 over the square root of 4, which is 2. So I get plus or minus the square root of 3 over 2. All right, so we need to decide if it's a positive or a negative value. So if I come back up here, x is in the first quadrant, and we're trying to find the cosine of x. You remember on the unit circle, this is your quadrant 1. Both cosine and sine are positive in the first quadrant there. So this is the positive value. So this is really the square root of 3 over 2 for the cosine of x. All right, so let's find the sine of y. So make sure you're using the cosine of y to go with the sine of y to find it. So this time I have to do cosine squared y plus sine squared y equals 1. I can put my cosine value of negative 3/5 in here. I can square this, I get 9/25. I can go ahead and subtract 9/25 from both sides. Get a common denominator. My common denominator is 25. So now I can go ahead and simplify the right-hand side. 25 minus 9, there's 16 over the common denominator of 25. All right, so now I'm going to take the square root of both sides. I'm not going to forget my plus or minus. So the sine of y equals plus or minus. The square root of 16 is 4. The square root of 25 there is 5. So now I'm going to come back up here, and it says y is in the third quadrant. The third quadrant is down here. And what about the ordered pairs down here? They're negative, negative. So your cosine is negative, which that's what we were given. And then your sine is also negative, which is what we want. So the sine of y is equal to negative 4/5. All right, so now let's use some of those double angle formulas. So now that we have all these values, let's find the double angle values. So again, just follow the formulas that you're given back there. Either pull up that Unit 4 identity sheet, or you wrote them down. So what does the sine of 2x equal according to the formula sheet? It equals 2 sine x times the cosine of x. All right, so we got 2. What's the sine of x? The sine of x is equal to 1/2 in the problem. What's the cosine of x? Well, we found that back on the other page there. It was a square root of 3 over 2. All right, so now what do? We can try to simplify things, or we could just multiply our numerators, multiply our denominators, and then reduce it down. Up to you. Reduce that down. We get the square root of 3 over 2. And your answer just becomes what it becomes. So square root of 3 over 2, that's your answer. Okay, cosine of 2x, you can decide whichever formula you want to use. There's 3 of them, you pick one. So I'm just going to pick cosine squared x minus sine squared x. So cosine x, we found that out to be the square root of 3 over 2 on the last page. Sine squared is 1/2. So if I square square root of 3, I end up getting square root of 9, which is 3. I square 2, I get 4. If I square 1, I get 1. If I square 4, I get 2, I get 4. Multiply my numerators, write down my common denominator, reduce it down, and I get 1/2. All right, the sine of 2y. So there's only one formula for that. It's 2 sine y. Make sure you use the y values, not the x values. So the sine of y, we found that on the last page. It was negative 4/5. The cosine of y, we're given that at the top of page here, which is negative 3/5. So now I can simply multiply my numerators and multiply my denominators, and I get 24/25. All right, so what about this one here? Since the sine of 60 is not equal to 2 sine 30, what does the sine of 60 equal? Well, we can use our our formula here to find this. We already know what the sine of 60 there is, but let's just use our formula here. So the sine of 2 times theta there is 2 sine theta. cosine theta. All right, so the sine of 60 is equal to the sine of 2 times 30 degrees. All right, and then, so this is like our theta in there. So we can just write this out. So theta here is 30 degrees. Because over here, let's look at this. It says a sine of 2 times theta, so we're going to treat this as a sine of 2 times 30. So that means the 2 is like out here, and this is sine 30, cosine of 30 this becomes. Because our theta there is 30 degrees. All right, so it becomes 2 sine 30 times the cosine of 30. All right, so on the unit circle again, this is my 30 degrees. At 30 degrees there we have the square root of 3 over 2 and 1/2. So remember your sine corresponds with your y values. So at y there we have 1/2. The cosine there corresponds with your x value, which is the square root of 3 over 2. So we can multiply our numerators, multiply our denominators, and then reduce that down. We already knew what the sine of 60 though was. We could just looked it up on the unit circle here. And it was 1/2 square root of 3 over 2. So the sine of 60 there, we already knew that was a square root of 3 over 2. But we can show that it's also equal using our double angle formula. All right, so we're supposed to simplify the expression using the double angle formula. So which double angle formula does this look like? Which one says 2 sine 35 cosine of 35? So hopefully you're thinking, oh, that double angle formula for sine looks like that because it's the second part of it. It's 2 sine theta cosine theta. So it's looking like that part right there. So what's theta in our case here? Our theta is 35 degrees. So we can simply substitute it in there. So we get sine 2 times 35 degrees, which gives us a sine of 70 degrees. So we have simplified that down. We didn't actually find the value, but we simplified it down. So it's just a sine of one value. All right, what's about the next one? Which one does that match? Oh, it matches the sine double angle formula for sine again. So sine of 2 theta equals 2 sine theta cosine theta. So this part here is matching this here. So what's theta? Theta is 22 degrees. So let's just plug it in there for theta. So we get the sine of 2 times 22, which gives us a sine of 44 degrees. There it is simplified. And again, it follows that formula right there. Those are your double angle formulas. All right, so we're supposed to simplify each of these using the double angle formula. So it looks like we've got tangent in each of these, this problem right here, and in the second problem over here as well. So it must have something to do with the double angle formula for tangent. What's the double angle formulas for tangent? Well, we're not going to use this one over here because it involves sine and cosine, and neither letter C or D there involves sine or cosine. So it must look something like this one. So you kind of look at the second part over it. Does it match? Yeah, it matches. So what's theta this time? Well, if you look at the second part here, it says 2 tangent of 5x. Well, tangent there, it looks almost like this. 2 tangent. This has theta, that has 5x. So our theta there is going to be 5x. So, and if you come down here, you can also see it here. 1 minus tan squared 5x. It says 1 minus tan squared theta. So what's theta? Theta is 5x. So let's just come over here and let's put 5x in there for theta. So we get the tangent of 2 times 5x, which is the tangent of 10x. All right, let's come over here and let's look at our other one here. So our other one over here is, we've got 2 tangent 13x and 1 minus tan squared 13x. So we're looking at this part over here. Notice the only thing that's different is instead of having a theta there, you have a 13x. So theta is equal to 13x. So what do we want to do with the theta equals 13x? We want to take that and we want to plug it in there for theta. So we get the tangent of 2 times 13x, which equals the tangent of 26x. So those are our double angle identities. So again, just use them exactly the way they're written and just plug the values in there. Sometimes you have to find some of the values first, but you're just using the double angle formulas to solve these.